Recording is in progress. All right, and I'm going to start sharing. So again, good morning. Workshop number 2 of 4 for us for project 3. Today we're generating the urban aggregation. We're just trying to sort of follow through and finish up the generation process that we started on Monday, right? So let's go back to where we left off. Just I guess I didn't have Rhino 7 firing up. Gotta wait for that for a moment. But again, we'll go through those motions. I'll recount what we went over on Monday. Make sure everybody can finish that up and generate this sort of urban aggregation across the city blocks that you have. I believe there's 9 city blocks, or I can't remember. It's been a whole 2 days. I don't know. Let's see here. I'll open it up here in Rhino. You can take a look. Yeah, so 3 squares, 3 by 3, so 9 building blocks. As you can see, you know, again, as just a quick refresher, towards the end of Monday, right? We talked about making your own sort of unit, right? Maybe there's a condo unit or something else that then gets sort of stacked using our cellular automaton, which is based off of Conway's Game of Life, right? So this was part of what I got sort of baked in to Rhino, right? So that's where we would like to be at today, is to sort of grow these things and bake them in, right? All right, so I'm gonna go ahead and turn this layer off and see if this makes my file lighter. It sure does. All right. So again, just a quick recap here. And in fact, I'm just going to, while Grasshopper is opening up, I'm just going to try to delete this layer and bake in more points here in a minute. What's really important is you understand that as you go through this process of generation, right, the information can really grow and expand pretty rapidly. And so with each generation, each tick in that slider in our Grasshopper graph, you generate more and more and more. And each of those units are consisting of various faces and surfaces, right? So these can get a bit heavy after a while, something to keep in mind. And it's always something to keep in mind. Again, the whole premise of this course is that if you're doing something that's not, you know, as you get to the end and you go, well, you know, the value proposition here is I want something really interesting. At the same time, I don't want it to, like, you know, I want it to be something that's possible, you know, with my computer and its memory and its processor, right? So it's not that much effort to go back in and change the configuration of points, erase some points, or turn down that slider so it's not as tall. If you have a result that's just weighing too heavy on your computer for your processor and things like that, right? So again, just a reminder there. So if I open up, let's see, this Grasshopper file that I gave you. There we are. Might take it a minute. I suspect I just saved it with everything going, so it's going to try to instantiate all those points and then instantiate all of the units across them. So it might take a minute. There we go. Back to, yes, there it is, right? Just waiting for it to kick in fully. That's kind of a short, I might make these taller. You know, I like these sort of ideas of hyperurbanism, just, you know, let's pack in some density here. Why not? Definitely a change from, I think, Las Vegas's urban core, but all right. Starting to see this thing grow. All right, you can see the, all of these green components aggregated. All right, and so the idea is that we'll look at the unit, we'll also look at the system, then we'll apply the unit to the system, and then bake the results in once you have a system that you think you like. Right? That's the end goal for the day. And if we get to it towards the end, you know, for those folks who are working a little bit ahead, we'll talk about how to you know, sort of think about it in a sort of immersive perspective inside of this thing, inside of this sort of faux cityscape, as well as then sort of where we're going with this sort of axon of the overall thing, sort of looking at it from a distance, right, from a ways back. Again, just waiting for this to respond. 203 megabyte file with all of those blue things baked in. That's why I might get rid of those if I can here. No reason to have the redundancy. I'm just waiting on, oddly, still waiting on Grasshopper and Rhino to respond here. All right, there we are. Okie dokie. I'm just going to delete my layer 3 that had the stuff I baked in from the last time, 3,517 objects. I just want to get rid of those. And at this point, you know, I'm looking at this. If I like this pattern, I'm just where I want to see what it does when it grows higher. Right. One thing you'll notice here is that if I go back, you know, I'm in the center of my Grasshopper graph, right? This with manual time control that has this sort of green circle around it. So this is set to 10 generations, or basically 10 stories, right? And so if I drag this manually, I can do that, but what you'll notice is that it starts to really slow down because it's trying to generate these things in real time. If I just wanted to like bump this up to, let's say 50 or 40 or something like that, so it's 4 times higher, I can just double click in here and then just modify it at once. And so instead of dragging it, it tries to do it all, you know, 20, 21, 22 in a step fashion. It'll just try to generate everything all at once. If I just type in 40 and hit enter, right? Just wanted to adjust that number slider just once, right? Just adjust its value and let Rhino crunch through here. All right, so here we go. Now they're taller. Look at that. Bam. So what you'll see is that it's taking a little bit, right? So it's getting through the first part of the graph pretty quickly, and that's just instantiating all of these points. You see all these little X's; those are points in Grasshopper, right? But what's taking a while now is at each of those points instantiating our unit. Now, just quickly talk about some of the widgets there on the sort of right-hand part of the graph, because you can actually play around with those if you want. They are there to sort of, again, apply some random shuffling and jittering and the sort of movement of these things, so they're not all just snapped to a perfect grid, but to sort of jumble them up and make them sort of look like they crash into each other just a bit. There's also some rotation. You can do a completely random rotation with any kind of angle, but what I've done in this instance that I gave you is to constrain the rotation at random, but only in 90-degree increments. So that way that they don't all look like they're facing the exact same way, but they start to rotate around, and so they look like they start to take into consideration their unique location among the system, and can start to look at different views and things like that, right? Just like you would think about in you were designing an urban tower. We're generating one, and so let's, or a set of them. Right. What's nice about these is that at the end, I'll get everybody's axons, and then I could actually arrange these into one mega city, right? Like blocks and blocks and blocks. I can take a Kimberly block and put it next to an Abigail block, and a Josh block, and a Megan block, and an Aliana block, and a Vili block, and etc. Right? And we can make this sort of aggregate city, which is pretty cool. Although I don't know if I have the processing power to do that. Maybe I can do that in Illustrator or something after the fact. But anyway, all right. So you can see here that it's updated, right? Okay. So I just wanted to sort of, again, make sure everybody is sort of on the same page as far as what we're trying to get up to today. Make sure my Grasshopper screen is up. If you get to this point soon, right? Let me just make sure my Grasshopper window is up here. Where is it? Come on, Grasshopper. It's odd. It's odd, but it's not odd, right? Anyway, then I'll just show you quickly some of these widgets, and then where you can bake these into Rhino really quickly, just so I make sure everybody's on the same page. Then what I'll do is I'll go back a couple of steps, right? So for those that need to follow along still, we'll look at these and we'll just go through it step by step one more time. All right. How many of you have a system like this already? I'm just sort of curious. If anybody does, feel free to shout out or put it in the chat box, I guess. No one. All right. No, Grasshopper was just underneath Rhino. That's dumb. All right. Thanks, Grasshopper. That's so handy. All right. So I'm just going to quickly zoom out here and let's take a look at this. So we've been looking at this timer. Again, we focused on the left-hand side here on Monday, and I'll go back through this again here in just a bit as a reminder. Right. Here's where we instantiated our component, right, to then move to each of these points that we provided over here with the cellular automaton. Right. So over here, I have a number of things, right? So one is I can determine the height of each successive generation, right? So right now I have it set to 6.9 units or feet, let's say, as far as how each unit goes up and higher. I could set that higher or lower, right? I'm not going to do that right now because it would take forever to regenerate this because I have it set for 40 generations. Okay. Then over here, I'm generating a random list of numbers and a random list of numbers, right? So what's interesting here is that I'm generating a random, oh, come on. Sorry, I don't know why this is being so, it's not like it's taking a lot to display these widgets on my screen or something. All right, so what I do is I have a domain from 0 to 3, and I'm plugging that into generating a list of random numbers. See, right? Between 0 and 3. How many random numbers? 11,584. That comes from basically just the number of units that I have, right? The number of points that my game of life is generated for me, right? And so I'm giving each of those little units that are being instantiated on each of those points a specific rotation angle. What I do is I take from 0 to 3 because then I can round those off to the nearest integer. So I have 0, 1, or 2, or 3, and I can just multiply that by 90, and then that's how I can constrain the random rotation to 90-degree increments, right? These show up as radians, so pi and half times pi and 1.5 times pi and 2 times pi, whatever, but annoyingly, but that's how these things get jumbled up. I also have a sort of generation. I think I randomize a sort of shift for these, right? So I'm jumbling these points around just a bit in Z and in X by generating a list of numbers between -2 and 2, right? To sort of move things up or down, left and right, or forward and backwards, just a little bit here and there in a random fashion so that we don't actually have a standard grid. I could actually let this be a standard grid, right? By simply bypassing this and pumping this into here, right? So anyway, just sort of throwing that out there, right? You could always look at this. If you dial this back so you don't have as many generations, then you can actually start to play around with these parameters until you get something that you like, and then you can go ahead and up that ticker again and let it grow some more, right? And that's the key thing here, depending on how fast or slow your computer is and how complex your widget here is, right? This is what's going to sort of determine how much memory and processing you need. Okay, so once I'm done, I can go ahead and take this and right click and bake it in. I'm just going to do that right now. I'm going to bake this on, let's say my layer 4 looks clear, so I'll put it on layer 4. I'll bake those bad boys in. Might take a minute or two for it to bake all of these polysurfaces in. In fact, it is not a huge surprise. All right. Okay. Roger does. Abigail says I'm caught up. Good. So what I'm going to do is I'm going to quickly go back through and sort of, try to figure out where everybody's at. And in that way, we can sort of keep going. All right. I want to make sure everybody's at this point by the end of today where we're baking things in. If you've already baked things in, then what you can always do is I'll just quickly go through a few things for those of you who want to experiment. But I think one of the key things is to turn off Grasshopper here. So Grasshopper closes as soon as it's done baking. That way I sort of know. Okay, there we go. But one of the things I would say is next is to sort of situate yourself in the perspective view. Come on now. It's not that heavy. I mean, yeesh. All right. I'll just sort of zoom in here quickly. Is to place yourself in here as if you're on one of these balconies or overhangs. And I'm also going to then go to the perspective label, the viewport label here. Come on. And go to Viewport Properties. The Properties box will show up over here on the right. I can set my camera settings here, and I'm just going to make sure that I have a wide angle so I can, look out across this sort of weird voxelscape that I have going on here. Maybe. This is going slower than I anticipated. That's great. Of course it is. All right, yeah, lens length of 50 millimeters, it's really tight. I actually have a low f-stop lens that's only 50 millimeter and doesn't zoom in or out. It's really hard to take. I mean, it makes you a better photographer trying to take good photographs with that thing, but 50 millimeters is a really tight sort of focus. I would, or zoom, I would zoom out a little more and give yourself a wider angle to work with. All right, I'm just going to sort of situate myself, but look for views that you can begin to frame here, and don't be afraid to sort of expand your viewport window or change its size. The other thing I would say is maybe let's just zoom out a bit, see what happens there. I might quickly accidentally put myself inside the geometry, in which case I need to zoom out or put myself in here again. But to sort of see myself within this sort of cityscape, I think will be really important. Once you start to get a perspective or two that you think you might be a good candidate, you can go ahead and again go to the viewport set view in named views. Right, you can save these views as you get them. So you can say like perspective 1. Right, there we go. And it'll pop up here. And then if I accidentally screw something up, I can always go back to that perspective later on, or begin to look at these candidate sort of perspectives to decide which one I like the best. All right, anyway. I'm going to turn this layer off, and yeah, everything looks a little better now. All right. Open up Grasshopper once more. Okay. I'm just going to clear the values here for this, and that'll make this a lot lighter for me here. Now I just have those points right in space. So again, everything generating these points in space boil down to these points that you create, right? So I created a bunch of points in Rhino. Each point in a cell designates that cell as being live, right? So again, if I go back to Grasshopper, let's just recap. I'm going to turn down here in the middle of my time controller, right? I'm going to go back to generation 0. That's just the initial starting conditions, right? And so you'll see that Grasshopper places a point inside each cell that has a Rhino point into it, right? So first things first, I can go here and place a point in Rhino in each cell that I wanted to sort of designate as live, right? Just keep adding some points here, as you can see. All right. And once I'm done adding points, sort of designating certain cells as on or off or live or dead, right? Again, I look at the overall graph here. The colored blobby circles and groups, those are the prompts for me to sort of zoom in and look at those, right? So this first one over here on the left, right click and set multiple points here. I'm just going to go ahead and clear the value so it looks like what yours might at home. Go ahead and right click, set multiple points. It's going to let me drag a box and select all these points in Rhino that I made. There we are. Oh yeah. And then hit enter or right click to accept. Right click and enter and space bar on, those are all mean the same thing. They all sort of are enter on your, so if you're using your right hand with the mouse, your dominant hand with the mouse and your non-dominant hand with the keyboard, that's how you develop muscle memory with any CAD program. AutoCAD, Revit, Rhino, 3D Studio Max, I mean, you name it, CATIA, whatever it is. Let's see. I'm just going to make sure that these are all in the points population. I wasn't so careful there. All right. Okay. So here we go. This is an alternate way to populate points. I'm just going to leave that for now, not worry about it. I've set these as multiple points. I can go over here now to the timer. I can move this timer up and start to build generation by generation up. Start to create. Let that cellular automaton start to make stuff, right? All right. Once I have a critical mass of points here, let's say 30 to 40 generations, let's say. I'll go with 38, I don't know, arbitrary number, but looks fine, right? I zoom out here. Again, we've set the points over here. I don't know if you guys can see this. We've set the points over here with this green purple blob. It turns green when I select it. We've set the timer over here. Next, right, it asks you to make the sort of unit that gets instantiated at each of these points, right? That's sort of, that part that then becomes, that makes up and gets aggregated a lot of times in order to make the whole sort of system, right? So all of these points are locations to aggregate those kit of parts in order to create these sort of CA systems, right? The sort of Conway game of life system. So here we go. Right, I can right click on here and say set one BREP. BREP is just a fancy term for polysurface, right? But now I need to actually make that unit. Right? So, and then you're really close after that. You're really close. So I'm just going to turn off Grasshopper for a moment. Let's take a look at these. I had given you guys 3 blocks in this this red layer called unit ingredients, right? So 3 sort of 10 by 10 by 10 cubes. And the goal here, and I'll just quickly model those so I have them again here. Really? All right. Sorry. So I'm just going to type in 0, 0, 0 for the first corner, 10, 10, 0 for the second corner, height of 10, enter. All right, now I have a cube. I'll move that away. I'll make 2 copies of this. All right. You can see what I did here with those 3, right? Over, oh, sorry. that wasn't helpful. You can tell it's like, it feels like a Friday today, doesn't it? All right, anyway, hopefully it does for you guys. I mean, I have like studio after this. I'm guessing most of you do too. And then it's all about eating stuff and probably putting up some Christmas lights sometime over the weekend and things like that. Anyway, so what I did is I composed the blocks and then used a set of Boolean commands, right? This is something brand new that a lot of you probably haven't played around with yet. Maybe you have, maybe you haven't, right? But both I mean by Boolean commands, right? Boolean, I guess, refers to a set of logics of true, false, and, or, nor, or. And Boolean actually derives from sort of philosophy, right? So this sort of set of logics. But when it comes to these sort of CAD environments, when we're talking about these sort of geometric Boolean commands like Boolean union, Boolean subtract, or Boolean difference, what we're usually dealing with is, taking 2 or more items and describing their relationship to each other, right? So we can Boolean union two things together, and two discrete objects then get trimmed out automatically and become one object, right? So we sort of you know, well, we form a union between them, right? I guess would be the difference. Boolean difference would be like a sort of Boolean subtract, right? You could you know, have two objects, and if they intersect each other, then one can take a bite out of the other, right? And that's kind of what I did here. I took a cube out of this cube, right? Then I unioned another cube with the resulting Boolean subtraction, right? The Boolean intersection then finds, let's say, where these two things actually intersect, just that volume where they coincide, that and everything else gets thrown away, right? So again, if I want to just quickly demonstrate this, right? In fact, what I'll do is for this, just the demonstration, you do not use spheres here, but just for the sake of this demonstration, I'll make a sphere just so you can sort of see the difference here in between the geometries, right? So for instance, Boolean difference, right? I'm in the solid tools. I pull those, click and drag and pull those out as a toolbar here, right? There's a lot of different solid tools. I'll do Boolean difference. So I go to the command line after I click the tool here. It says select the surfaces to subtract from. So I'm gonna go ahead and select this cube and then right click to enter. Select the surfaces to subtract with. I'll go ahead and select the sphere and right click to enter. Now you can see I've taken a bite. I've subtracted the sphere away, the part of the sphere away from the cube, right? I could also, and you can see here in the X-ray view, hopefully you can see that, these two things intersect each other, right? You can see that the sphere continues on through the cube and the cube continues on through the sphere. If I wanted to union them together, I go ahead and do that. I'll go ahead and select this one and this one. Now you can see that they actually trim each other out to become one solid closed polysurface or BREP, right? Last but not least, the sort of opposite almost of the difference command, right? To find the intersection. So I just want to have the intersected pieces left over. Okay, let's see. Do that, select the first set of surfaces. So I'll go ahead and select this one and right click to enter. Then the second set and right click to enter. Now I just have the part where they both intersected and everything else disappears, right? So, and you can see that quite clearly from the, the sphere versus the cube, right? Now don't use a sphere for this. I want to have this sort of Euclidean logic here that deals with X, Y, and Z axis. So that's kind of why I wanted to sort of constrain you guys a little bit here. But anyway, so again, how I derive this shape, for instance, not that you want to do this exact shape or anything that I have. Or maybe I'll just make a different kind. Here, I'll just do this. I'll move this away. Let's see. Let's say 2 units this direction. And 6 units in this direction. Let's see here. And I'll make a copy of this one. Instead of using this copy over here, I'll just make a copy of this one since it's already in line. What I want to do. I'll move this over, let's say 8 units. 10 units. 2 more units, let's say. Yeah, all right. Now I'll just move these up, let's say 2 units. I'm just sort of, again, I'm just playing around. There's no real rhyme or reason to this except to make an interesting shape. So maybe I'll just do a Boolean subtract here. Boolean difference. I'll subtract from this with these. I'll go ahead and get rid of those old ones. Right, now I have this. Right, so maybe I make that my new unit here. All right, so I'll go back to Grasshopper. Okay. And now again, I've done the purple stuff in the front end here. I've adjusted the slider. I'm going to adjust that slider down a little bit so it doesn't take so long to generate these. Adjust this down a bit so it's not quite as tall. There's not as many points. I go down to the middle here, right? Use this to reference your unit. Okay, so I'm going to go ahead and right click, set one brep, select my poly surface in Rhino. All right, now it's going to take, Grasshopper is going to take a moment or two to then place each of these units right here, right? Now, what's interesting is I think since you'll see, but this will be really interesting because I think these will be shifted in a different place than I want them, okay? And so we'll talk about that. If you're having the same problem at home, I'll talk you through how, what the problem is there. But basically, I think that when it's doing the move command or the copy command to make a series of copies of these at each of these points, it's using the reference point, the 0, 0, 0 point, the Cartesian coordinate space as a reference point, and then using all of these other points as target points. And so what happens is that if this isn't situated on that point, then that 0, 0, 0 point, then things will be shifted over whatever this distance is. And so let's just see what happens here. But in order to fix that, I'm just going to basically snap one of these bottom corners of this unit to the 0, 0, 0 point here in a minute in order to fix that. I just realized that after I referenced it in. Okay, so how many of you are following along right now with this step? You have a unit and you're just trying to put it in, and I'm kind of curious. It's hard to sort of tell. I can't see facial expressions or anything. I can't run around the room and look over anybody's shoulder. Sorry, I'm just trying to tie my shoe as well. But I'm just sort of curious to sort of know, you know, how everybody's doing. And I want to make sure that these count. Following along, says Daniel. Okay, good. So you can actually see here at the top view, right? It's pretty interesting. So all of these things have shifted over the same distance that whatever this original unit was from the the 0, 0, 0 point in XYZ Cartesian coordinate space. So what I'm going to do, I'm going to quickly try to twist this around, and I'm just going to move this. I'll move this over, turn my snaps on, say a midpoint. Try to find a midpoint. Turn my object snaps on, end, mid. Okay, here we go. Try to find the midpoint there as the point to move from, and the point to move to. I'm just going to type in 0, 0, 0. You'll see that actually pop up here in the command line, hopefully. There we go. And hit enter. And it should move over. And then as I make that change, then the change, this is referenced into Grasshopper at that point in the mind map, the graph. So all these changes will propagate here, and it'll take a few minutes to do that, or maybe a minute or so to do that. Bit laggy here, but that's the interesting thing, right? I mean, what's I think really kind of critical to understand here is that we're purposefully using our digital technologies and these sort of generative systems that these things enable or empower us to use in order to do something that inherently is too complex for us to do with pencil and paper, right? And so I would actually argue that, the tools sort of, we shape our tools, but then the tools start to begin to shape how we do things and how we leverage things. And more in the building industry, these things are happening, right? How many of you, maybe as part of AIAS, went to go see the MGM sphere construction site going on, right? Doubly curved surfaces, approximated as faceted information. That's a really complex project, right? It's not that you couldn't do that without a computer, but it would take a lot longer, and there'd be a lot more errors, and the budget would have been exploded. It just would have blown up big time had it not been for digital technology to help manage all that information, right? Imagine the design information, then the engineering information, then all of the sort of fabrication information, the construction information, how to assemble things, all the shop drawings and all that other stuff, right? Another good example is the other populous building here, the Raiders Stadium, right? That went up relatively quickly in the middle of a freaking global pandemic. Again, if you look at the complexity of that shape and then how the facade is articulated, the envelope, a lot of that has to do with, again, managing the digital information, right? So just as some quick examples. And then a pioneer at a certain time in sort of really sort of pushing the boundaries of how to manage information. Frank Geary's office, right? You know, if you ever go to the Lou Rouveau Center over by the Smith Center and all that other stuff, in Symphony Park over by downtown, you know, again, that would not have been possible or would have been very difficult to do pre-digital. So again, what's interesting is that, you know, as you track architecture over long periods of time, you start to see all these changes, both in terms of style, but also in terms of form, embellishment, material use. But they're all largely influenced by the technologies at the time, right? And I would argue that digital technologies have intensified how things are made and used. And it's just a matter of time for that to really, I think, infiltrate and transform the building industry. The building industry is a little slower than some of these other industries. If you look at how, like, say, the automotive industry has changed, it's happening very quickly, and it already has happened very quickly. If you look at how items like these, I'm trying to hold up my iPhone, right, the smartphone, or anything else. You know, it's absolutely stunning how quickly things have changed when it comes to shape, form factor, complexity, embedding digital technologies in them to make them smarter, more efficient, or to track you, or whatever it is, right? Whether it's to sell more ads or to, you know, or to basically be able to suggest, you know, the other things that you might want to purchase on Amazon because other people like these things, or whatever it is, right? But the premise here, I think, is that, you know, theoretically things are changing, and hopefully for the better. We'll see. I think that's the other conversation that architects need to contribute to more, is what direction progress truly is. I think that's more of a philosophical and ethical question. I don't think technologists and computer programmers are necessarily equipped to deal with those questions. And I think anybody that I think a lot of people need to be around the table to sort of talk about that. But anyway, let's see here. Right. So finally, this thing is instantiated. You can see it right here. Don't take my word for it. There we go. Right. Bam. Look at that. Looks like a whole cityscape full of balconies and rooftop gardens and you know, potentially window walls and things like that, right? So, all right. Okay. So once you get that done, right, the end goal again is to be able to go back here where all these things are finally rotated and shifted and all that, and right click and say bake, and bake that into its own layer in Rhino. Okay. So for those of you who are ready to move past that, a sneak preview of what's coming next Monday after we celebrate 4-day weekend holiday. So let's see here. Just turn that off. Yeah, there we go. Right. There's a couple of things we're going to think about here. So I just talked briefly about perspective, but let's talk about the axon, right? I'm just going to come over here and I'm going to set my view to isometric. And I'm going to toggle back and forth between northeast, northwest, southeast, and southwest and try to find the one that I like the most. So there we go. Look, it's all fit to screen for me. That's kind of nice. That one's not so bad. That's definitely a possibility, unless I see something that just looks incredible. So let's go with northwest and see what that looks like. Northwest. Now I'm starting to see some things that are floating. So what you'll notice is that as it generates points off the grid, let's say on one edge, they show up on the other edge, the corresponding edge, almost like if this was wrapped in as a sphere around the world, right? So if this was like an unrolled map of the universe, and I don't just fall off the Pacific Ocean into space, right? I would show back up on the other side of the map, right? So that's kind of interesting. So we have some floating science fiction here. So maybe I don't pick that one. If I really want this one, I would have maybe start to select some of these things and delete them away, right? Just make some artistic, take some artistic liberty, make some solid decisions here so that I can move forward. Same thing with the southeast. I'm getting a couple of dramatic cantilevers and then some things just sort of floating, some floaters out here, you might say. So set view, isometric, southwest. Let's see what southwest looks like. That first view is looking pretty good. Southwest, I might just, a couple of these are really showing up as just being really out there. I don't think I'm gonna hate it if I just sort of get rid of a few of these things that are just floating. Just be a few more or a few less poly surfaces to contend with anyway when it comes to the memory and processing and computation side of things. So go ahead and just delete some of these away as I go back through. And I'll just, again, I'm just taking some artistic liberties here. Yeah, okay. I'll just go back through sequentially here and see if anything changed when I look at the southeast view, let's say. It's not so bad, actually. Interesting. I might get rid of these two stragglers out here. They look a little out of place. They were there for the first generation. They didn't have any neighbors, so they just died immediately, in the next generation. Kind of sad, really. Anyway. The other thing is I'm seeing the original component over here. If I'm careful, I can turn off my points and turn off these unit ingredients. I can lock my city layer, city blocks and roads layer, so I don't accidentally drag anything out of place while I'm selecting parts to delete. All right. Just trying to keep things organized. Isometric, northwest. See if I see any floaters out here. I think I sort of took care of the major floaters. There's one right there. That one looks a little out of place now. It looks kind of dumb, but all right. Try this one more time. I'm just going to go over back to the northeast and let's double check. I might go with the northeast, although the northwest didn't look so bad either. Now, there's another floater right there. Now that's popping up. Get rid of that dude. You're gone. Boom. All right. Yeah, I actually kind of like the southwest. Maybe I'll go with the southwest or northwest now. There we go. You can start to see some differentiation, some gaps here in between some things. It starts to really begin, I think, to sort of spell out that these things are cells that sort of cascade on top of each other downwards and are stacked in different ways. Kind of weird. All right. There's a couple of other things that we need to do to sort of prep for our make 2D operation, right? So if I do a make 2D now, just zoom in here really quickly before I zoom back out. Oh, come on. See where all these things intersect? All of those intersected edges will not, there won't be any lines there for my line drawing in the make 2D, right? So I only get these sort of edges that are between surfaces and the outer edges and things like that. So what I need to do is I need to run the intersection command, right? Kind of a pain in the rear because this will take a while. And I'm going to go ahead and save my file in case I just need to end this. Okay. But again, just to sort of think about this, we'll recap this part on Monday when we come back to sort of make these beautiful make 2D axon drawings. But what I'm going to do is I'm going to run the intersect command in Rhino here. Intersect. Select the objects to intersect. I just want to make sure I just select this, right? All the pink things. There we are. Oh, you know what? I'm also going to unlock the city blocks. I want to make sure if anything like sort of is embedded slightly within the city or like the block, the ground, I'll hold down the shift key. I'm also going to give it the city blocks. Why not? There we go. At least the ones we can see over here. Again, once I've selected this view, I don't necessarily need to calculate all the intersections with any of the city blocks that I don't see here in this axon view. All right. I'm going to put these on their own layers. I'm going to make layer 5 a new layer, the active layer. All right, I'm going to change the layer color from white so I can actually see it here. Select all the objects that intersect. When I'm done selecting all that stuff, I'm going to hit enter, and it's going to take a while. And it's going to calculate all the intersections between all of these surfaces and polysurfaces. It's going to give me curves or lines at all of those edges, those intersections events. All right. So this might take a while. And again, it's one of those things where I just sort of budget some time, let this play out. While this is playing out and I see this sort of blue spinning wheel, let's have a quick discussion. I'm just sort of curious to see how this is going. So Daniel, you're following along. Have you baked in your objects yet? How many people have baked in their objects now? Yee, all right.
I have.
I hear yeet from someone. Who else? I have, great. So Roger, you're probably bored now, right? Getting there. So Abigail's close. Excellent. Anyone else just performing this step with me right now? I know you have Rhino up, you have probably limited screen space. I mean, that's one of the bad parts of doing, remote over Zoom, right? Is that it might not be so easy to stop what you're doing and type in the chat or try to unmute yourself or something, but feel free to speak up, right? I kind of want to make sure if anybody's feeling behind that we get you caught up here, all right? But this is what I'm working on right now. I want to make sure everybody's baked in. Gets baked before Thanksgiving. You could take that the completely wrong way if I said that out loud with minus the context, right? So, all right, let's see here. You can see it's, again, there's quite a few items to sort of, basically taking each item in this list of stuff we gave it and comparing it to every other item, looking to see if they intersect. And if so, then finding all those events and drawing all the edge curves accordingly, right? All those intersections. So what's interesting is that then when we have all those lines, those intersection lines, we'll include those with our Make 2D so that they're actually drawn in our Make 2D, our flattened sort of axon drawing, all right? Taking a while, taking a long, long while. All right, still going. Like I said, this can take a few minutes, so it's worth, if you're at this point, make sure you save things and then try it out. So a couple of other things to mention here is once you start to do a lot of operations that take a lot of time, you're starting to generate a lot of information. Windows can sort of come back with I've run out of virtual memory or something like that. So if you get that kind of thing where it says Windows ran out of virtual memory or you're out of scratch space or something, right? Well, those are two separate things. So if you run out of virtual memory, what that means is that you need to close, save and close. You need to reboot your machine so that you basically, it'll clear out all the memory that that your computer had been using. If you were doing lots of different things over time, you haven't restarted in a while, sometimes you run out of virtual memory once you're doing something pretty memory intensive. If it says you're running out of scratch disk space, what that means is that a certain portion of your hard drive is used also for sort of random temporary memory, right? Temporary storage purposes. And if you're really running low on hard disk space, like your hard drive is mostly full, then you need to clear out more space. You need to do that for lots of different applications. The Adobe applications, the Autodesk applications, so Revit, Photoshop, sorry, not AutoCAD, Photoshop, sometimes Illustrator. Rhino is no exception to that. Anything that requires that graphics card, a decent graphics card, and decent set of memory and decent processor. Oftentimes we'll utilize scratch disk space. Okay, so if you run into those issues, you can let me know, but that's you know, those are the two things I'll tell you to do. Double check your hard drive, make sure that you have you know, a decent amount of space on there, probably get at least a gigabyte, if not more, on your hard drive of just open space. And then the other thing it would be to reboot your machine, right? So if you're out of memory or your processor is really taking a long time, you know, another thing to do is you can see here, probably I have a couple of apps open. You know, I'm just probably just like you guys, you know, I have a browser open with tabs that have been up for a couple of months, it seems like, because I just haven't followed up on certain things, or, you know, Spotify or something like that, right? You can always turn those things off. They're also using system resources. So if you're doing something that's super intensive resource-wise, sometimes it helps us to run that one thing and let it go, right? If this is taking a long time, you know, do it on a Friday night when you're just going to let your computer sit there while you're not even at it. And let's let it, you know, take an hour to crank this out. I'm kind of curious to see how long this takes. I thought in Rhino 7 that it actually gives you a progress bar here along the bottom right, but apparently it doesn't. So I'm just going to, you know, let this go for a few more minutes, right? But once this happens, then I could theoretically do a make 2D. The make 2D, I believe, does give you a progress bar, so you can sort of see where you are in this sort of process, you know, how long it's taking and how long it will take to finish this up, right? So if this is taking an exceptionally long time and it's running out of space or running out of virtual memory, you can always select certain portions of this and just do portions of it at a time, you know, and then you know, so there's lots of different ways to sort of be creative in a pinch here, unfortunately, but that's one of them. Just going to let it sit here and crunch numbers. All right. If you're not at this point, don't worry. We'll look at this on Monday again. Okay. I have a feeling, given the amount of memory and just the amount of stuff in here, that we might just do the axons, or just do the axon for each of these. But while this is going on, I'll just quickly talk a little bit about the perspective stuff. And if we get to it this next week, then we will. And if we're not, then we won't. But I think it's worth just sort of quickly talking about, because it'll be a little bit of a rehash from the last time we used Photoshop in Project 1, right? So let's see, fall 2020. Let's see if I can find some of these demonstration files really quickly to help out with this. I have several folders here, sort of, you know, looking at these. Ah, yes. Okay. So I'll just go through these quickly, right? But there's nothing too crazy here, right? So, you know, here's taking one, creating a sort of finding some concrete textures and creating an overlay layer. So creating a sort of a mask layer just over, let's say, the units. Then using that to trim out this sort of concrete layer, adding some perspective to the concrete layer, this texture, making an overlay to sort of overlay over this. Let's say looking at some of these vertical and horizontals, adding some textures here and there, using the brush to sort of burn, dodge, or add shadow different places, adding a sky, adding some birds or some other entourage, doing these sorts of things, maybe giving it a softer look, but the Gaussian blur, giving it a color map, giving it some solar flare, etc. Right? Sort of thinking about coloration, color theory. I think that's the starting point. You know, for, let's say, some of these perspectives. Here's another one, again, softening things up. There's a set of axons, right? Here's a perspective. Okay. That's ugly. Now here's one that went over the top, right? Like it just, I mean, it just looks like, you know, aggregate city. It looks like the city, there's nothing, no ground plane. In fact, what I did, interestingly here, is I generated stuff to make the sort of the ground a sort of pixelscape, right? Sort of pushes up and down. Then I added some tubes, you know, some sort of infrastructure, let's say Hyperloop sort of tunnels or something like that through the city vertically in different directions. I just had fun with it, right? You don't necessarily have to do that, but let's see. Here's one where I added some sort of normative buildings and made it look like these things were sort of grafted and climbing up on them like a sort of parasite. Again, just sort of taking out some quick perspectives and then dressing them up in Photoshop to give it some atmospherics. Right. So again, I was just experimenting around with this stuff, but you know, again, it doesn't take much to sort of, again, start to apply some textures. Maybe it's part concrete, maybe it's part wood, something warm, maybe it's part glass to sort of, you know, spruce these things up, add contrast to it, you know, start to paint them things. These are all just maps that I found and started to apply various ways, right? All right. And much to my chagrin, this is still going. So I'm going to go ahead and stop sharing. And in the spirit of the workshop, I'm stop recording.